Let us now solve few questions from NCERT exemplar. To begin with, we will solve the questions from exercise 1.1. Choose the correct answer from the given four options in the following questions. Question 1. For some integer m, every even integer is of the form option A m, option B m plus 1, option C 2m, option D 2m plus 1. We have learned in our previous discussion that even integer will be multiple of 2 and odd integer will be 1 more than the multiple of 2. Therefore, the right option is option C 2m. Look at second question. For some integer q, every odd integer is of the form option A q, option B q plus 1, option C 2q, option D 2q plus 1. And the right answer is 2q plus 1. As I discussed in the previous question, 2m is for given number 1 more than 2m format will be for odd numbers. Look at question 3. N square minus 1 is divisible by 8 if n is option A an integer, option B a natural number, option C an odd integer, option D an even integer. To arrive at the conclusion, we have to solve in a reverse order. We have learned in our previous discussion that every odd integer, let me write it here, every odd integer will be of the form either 4m plus 1 or 4m plus 3. Now with these two forms, I need to check whether n square minus 1 is divisible by 8. For that, in the place of n, let me consider 4m plus 1, square it minus 1 and expand it. I'll be getting 16m square plus 1 plus 8m minus 1. This minus 1 and plus 1 they get cancelled. I'll be getting 8m common times of 2m plus 1, and it is very clear it is 8 multiplied to m times of 2m plus 1, so it is divisible by 8. Will this be true if n value is 4m plus 3? Let's find out. When we expand, it becomes 16m square plus 24m plus 9 minus 1. Further, I can express this as 8 times of 2m square plus 3m plus 1. So it is 8 multiplied to this. So when it is 4m plus 3 also, it is divisible by 8. Therefore, the right answer is option C, an odd integer. Look at question 4. If the highest common factor of 65 and 117 is expressible in the form of 65m minus 117, then find the value of m. Here we need to find out the highest common factor of 65 and 117. For that, let me take a division method, a simple method to find out the highest common factor. 65 one time is 65. On subtraction, we get 52. Now I need to divide this 65. One time is 52 and 13 remains. Now I need to divide 52. 4 times is 52. Remainder is 0. So the divisor when the remainder is 0 is 13. Therefore the highest common factor is 13. Now this highest common factor is expressible as 65m minus 107 as per the question. So I need to equate it to 13. Let me find the value of m. This will be 13 added to 117 divided by 65. This is 130 divided by 65. It is 2 times. Therefore, the right answer is option B, 2. Let us solve fifth question. The largest number which divides 70 and 125, leaving remainders 5 and 8 respectively is. So here we need to find out the highest common factor of the numbers 70 minus 5, 125 minus 8. Nothing but the highest common factor of 65 and 117. In the previous question we have seen the highest common factor is 13. So the right answer is option A, 13. Sixth question. If two positive integers a and b are written as a equal to x cube y square and b is equal to xy cube, where x and y are prime numbers, then the highest common factor of a and b is. Highest common factor, we need to find out the common factor here which is having the lowest power. So option B, x y square is the right answer. Similar to this, we have seventh question wherein we have to find out the least common multiple of p and q. Least common multiple means we have to consider all the factors along with their highest power. So the right option is option C, a cube p square. Question 8. The product of a non-zero rational and an irrational number is. It is always an irrational number. The reason is, if you take some non-zero rational number, say 5, multiplied to an irrational number, 5 times of root 5 is 5 root 5. This 5 root 5 is an irrational number. So always it will be an irrational number. Let us solve the ninth question. The least number that is divisible by all the numbers from 1 to 10, both inclusive, is option A 10, option B 100, option C 504, option D 2520. To find the least number that is divisible by numbers 1 to 10, we need to find out the LCM of numbers 6, 7, 8, 9 and 10. To find the LCM, I'll start dividing 2 to 3 times 7 as it is, to 4 times 9 as it is, 5 times. Further, I'll divide by 2, so 3 as it is, 7 as it is, to 2 times 9 as it is, 5 as it is. Now shall divide by 3. 3 1 time, 7 as it is, 2 as it is, 3 times 5 as it is. Now the least common multiple is 2 cube multiplied to 3 square multiplied to 5 multiplied to 7, and this product will be 2520. So the right answer is 2520. Look at 10th question. The decimal expansion of the rational number 14,587 upon 1,250 will terminate after option A 1 decimal place, option B 2 decimal places, option C 3 decimal places, and option D 4 decimal places. To find at what particular decimal place it terminates, I need to consider the denominator. The denominator here is 1250. Let me prime factorize this. If you prime factorize it to 625 times is 1250, 5 125 times, 5 25 times, 5 5 times. So 1250 is nothing but 2 multiplied to 5 raised to the power 4. So this number is same as the numerator upon 2 multiplied to 5 raised to the power 4. Let me multiply and divide by 2 cube so that this denominator is the product of tens and the denominator becomes numerator into 2 cube upon 10 raised to the power 4. So after 4 decimal places it terminates. Now let us solve exercise 1.2. In this exercise we have short answer type question. The first question is, write whether every positive integer can be of the form 4q plus 2 where q is an integer. Your answer is no. The reason is we have solved a question and we have taken a be a positive integer and we have taken the value of b as 4. This implies a can be written as 4q plus r. Condition is 0 less than or equal to r less than 4. So r will take the values either 0 or 1 or 2 or 3. Suppose if the value of r is 0, then a is 4q. Suppose the value of r is 1, then the value of a is 4q plus 1. Suppose the value of r is 2, then a is 4q plus 2. Suppose the value of r is 3, then a is 4q plus 3. So when you observe it, not only 4q plus 2, we have 4q plus 3 form, 4q form, 4q plus 1 form. So the answer is no. Look at the second one. Product of two consecutive positive integers is divisible by 2. Is this statement true or false? And this statement is true. The reason is, here the product of two consecutive positive integers, if you consider it as 2, the next integer is 3. If you consider as 3, the next integer is 4. In other words, every time you'll be having this format, it's an even number multiplied to an odd number. We know that even number is divisible by 2. Therefore, the product is divisible by 2. Product is divisible by 2. So the answer is true. Third question. The product of three consecutive positive integers is divisible by 6. Is this statement true or false? This statement is true. The reason is, out of three consecutive positive integers, it is divisible by 2 and other by 3. So the product is divisible by 6. If you multiply 3 consecutive integers, this number is divisible by 2, this number will be divisible by 3. So this product is divisible by 6. Therefore, this statement is true. Question 4. Write whether the square of any positive integer can be of form 3m plus 2, where m is a natural number. Justify your answer. The answer is no, because every positive integer is of the form 3q plus 1 or 3q plus 2. Now if you consider the square, 3q whole square will be 9q square, which is equal to 3 times of 3q square, nothing but 3m form, where m is 3q square. Same way, if you square this 3q plus 1 whole square, we will be getting 3 times of 3q square plus 2q plus 1, which is 3m plus 1 form. And similarly, if you take 3q plus 2 whole square, will be 3 times of tq square plus 4q plus 1 added to 1, nothing but 3m plus 1 form. So we are not getting 3m plus 2. Therefore, the answer is no. Question 5. A positive integer is of the form 3q plus 1, q being a natural number. Can you write its square in any form other than 3m plus 1? That is 3m or 3m plus 2 for some integer m. Justify your answer. The answer for this question is no. The reason is, if you consider the number as 3m plus 1 form, if you take the square of that number, this will become 9q square plus 6q plus 1. You can take 3 common in first two terms. It becomes 3q square plus 2 added to 1, which is 3m plus 1 form, where m is some positive integer. Therefore, the square is not in 3m or 3m plus 2 format for some integer m. Question 6. The numbers 525 and 3000 are both divisible by 3, 5, 15, 25 and 75. What is the highest common factor of 525 and 3000? It's very clear that here they have mentioned the numbers 3, 5, 15, 25, 75 are the divisors of both these numbers. So the highest common factor of 525 and 3000 is 75, as 75 is the largest number which is dividing both 525 and 3000. Question 7. Explain why 3 multiplied to 5 multiplied to 7 added to 7 is a composite number. 3 into 5 into 7 plus 7 is a composite number. The reason is, this can be written as 7 multiplied to 3 into 5 plus 1. It is nothing but 7 multiplied to 16. Here 16 is composite. So 7 into 16 is also composite. Composite means it is having more than factors. Can two numbers have 18 as their highest common factor and 380 as their least common multiple? Give reason. The answer is no. The reason is 18 is not a factor of 380. Question 9. Without actually performing the long division, find if 987 upon 10500 have a terminating decimal or a non-terminating recurring decimal. To do this, let us express the denominator as product of prime. So numerator as it is divided by, express this as product of prime, let me divide 105 with 3, it goes 35, 5 7 times. So rest is 100. 100 is 25 4 times. So 2 square into 5 square. So this can be written as 2 square into, for 100 it is 4 into 25. Here for 105 there is one more 5. So finally it is 5 cube multiplied to 3 multiplied to 7. Now observe, on simplification you can divide this and we get it as 329 times. Further this is divisible by 747 times. So the result is 47 divided by 2 square into 5 cube. This denominator, observe only the denominator. This denominator is purely of the form 2 to the power of m into 5 to the power n. Therefore, this particular number is a terminating decimal. It terminates. Look at question number 10. A rational number in its decimal expansion is 327.7081. What can you say about the prime factor of q when this number is expressed in p by q form? Look at the number clearly. 327.708. This number 327.7081 is terminating. This means in p by q form, q is of the form 2 to the power of m into 5 to the power of n, where m and n are whole numbers. Therefore, we can say that this particular prime factor will be the product of 2's and 5's